Hi all, I want to introduce you to a new chapter today. The first chapter we'll be doing during lockdown is something called Indices. This is chapter 7 in the higher level book. Don't worry, this is all available on Google Classroom. If you don't have a physical copy of the book with you, I have put up screenshots of the chapter for you. So I would like you to read just the introductory pieces here at the start in your own time. But Indices is something that you've all seen in first year at different stages of the year. And indices are numbers that we use often to speed us up in maths. So especially when I'm dealing with very large numbers, it can be better actually sometimes to represent it as an indice. So an example here would be 2 to the power of 3. Okay, so if I have 2 to the power of 3 here in front of me, well, that means I have a normal number 2. We could call that a base number. And I know this is an indice because it is a smaller number on the top right-hand corner of the base number. So 2 to the power of 3, or you could say 2 cubed. Now, I have a job here, and the job I'm being asked to do is to expand and then simplify the numbers. So I've done the first one there for you. So expanding it basically means, like, what does 2 cubed really mean? 2 cubed means 2 multiplied by itself and multiplied by itself again. So I have 2 by 2 by 2. That'll give you a value of 8. So I've expanded and I've simplified down, and my simplified answer is 8. What if I was to repeat that? And I was to repeat that for minus 7 and cubed. So minus 7 cubed. So minus 7 cubed for this one, again, means I have a value here of minus 7 by minus 7 and by minus 7. Now that'll take a little bit of a moment there to load up. There's a little bit of a lag. So I have minus 7 multiplied by itself again. You have to be very careful when you're dealing with negative numbers. Okay, negative numbers can cause awful difficulties because people forget that you're dealing with a number multiplied by itself and by itself again. So what will happen here, you might notice, is that the minus by the minus will give you a plus, but then that plus will give you a minus value at the very end. So in other words, if I work this out with my calculator, minus 7 by minus 7 will give us 49, and then 49 by 7 is going to give you, sorry, that's not just a 7, but it's a minus 7. That'll give you minus a minus 343. So your answer there, when it's simplified, is going to be minus 343 on that one. So when you're talking about indices, it's important just to, first of all, recognize what it means. It means you're multiplying out this base number by itself, however many times. Okay? It does not mean that it's 2 multiplied by 3. It does not mean it's minus 7 multiplied by 3. That would be a common mistake on this one. Now, we'll be looking at examples of where this is useful in future, but indices are especially important for things like population growth. So, for example, if I know that the population is going to double, let's say I start off with 8 people, and in a certain amount of time, I know the population is going to double. In other words, it's going to become 16. Well, I can use indices to make life easy for myself when I'm dealing with big population numbers. So what I could do is I could represent that as an indice. That would be 2 to the power of 4, and expanded, that would be 2 by 2 by 2 by 2, which will give you 16. And that's very useful for me when I'm dealing with population numbers and big population numbers. So, for example, for bacteria, the populations can be very, very big, and we know that the populations of bacteria often double every 20 minutes. So you can get a good idea using indices of like how much growth is going to happen in the population. So jumping back to what we're doing here, a few questions that you'll be working on will be asking you to do things like this. I have 3 quarters, 3 to the power of 4 multiplied by 3 to the power of 6. So in other words, I have a number and an indice, and a number and an indice. And what's very important here, and I should recognize, is that I've got the same base number, in this case, which is 3. So to solve this, there's a rule of indices, and the rule states that if the base number, in other words, 3 in this case, is the same, then I can follow. What I can do is I can add the indices together. So in other words, that's going to be 3 to the power of 4 plus 6. Okay, and I can only do that because I'm dealing with the same base number. When I work that out, I will get 3. I will get 3 to the power of 10. Now, 3 to the power of 10. How can I confirm that this answer is correct? Well, you could do it 2 ways. You could use your calculator, and you could work out what is 3 to the power of 4 multiplied by 3 to the power of 6, and you'll get a number for that. And you can compare to 3 to the power of 10, and you'll end up with the same value. You'll end up with the same number when you work it out using the calculator, either by working out this or working out this in your calculator. Okay, so the rule is, if you're multiplying a number and an indice by a number and an indice, and they're the same base number, you can actually add the indices together, and you'll get a value there of that you can simplify as 3 to the power of 10 in this case. What if I'm dividing? Well, it's very similar. We're going to rewrite this as 5 to the power of 8 over 5 to the power of 3. Okay, now the reason I can rewrite that is because division, if you think about it, a fraction like this really means division. 5 to the power of 8 over 5 to the power of 3 means 5 to the power of 8 divided by 5 to the power of 3. Now again, I should recognize, if I look here at this, that I have got a base number which is the same. I have got 5 and I have got another 5 here. So this is actually the direct opposite. What you're going to do in this case is you're going to keep the base number, which is 5, and you're going to subtract the indices. 8 minus 3. And again, for this one, you're talking about getting a value there of 5 to the power of 5 for this one, because I've subtracted my numbers, my indices, and I ended up with a value of 5. So 5 to the power of 5 for that one. So that is how you work out your indices following those 2 rules. Multiplication, I add the indices together. Division, I subtract the indices from each other. And follow this format for this, please. So what kind of questions will we encounter in this when we do this for homework? Well, if you look here, this is not loading very well. Hold on. So hopefully you can see what I can see in front of me here, which is a question here, question 3, which says, copy and complete the following tables. I have to represent this I'm given it in index notation, so 2 to the power of 1, and I have to write it as a whole number, but your 2 to the power of 1 is just 2, so I can write down 2 there. Again, I have to correspond 2 squared as a whole number, and that would be 4. So you just work it out there, and you can actually use your calculator for this. Now on your calculator, you'll find the button, and that button is there should be an x squared, there should be an x cubed, and also there should be a third one, which is x, and there's like a box on the top right hand corner of it. What you can do is you can click on the if I, for example, I want to figure out 2 to the power of 4 using my calculator. What I can do is I can write in 2, and I can click this X box that's underneath it's underneath the arrows. If you look at there, I'm sure you'll all find it. When you click that in, a box appears. You click in the number you're interested in. So in this case, I'm interested in 4, and you click equal, and it gives me a value there. So 2 to the power of 4 gives me a value of 16. So if you have any trouble with that, let me know. I can't figure out how to put that up on the screen, as I don't have the emulator. But that is just an introduction to algebra, or to indices, and we'll continue at a later stage.